The main nuts and bolts coding things that you need to understand to do exhaustive search or brute force search is how to use nested for loops. So I just wanted to rapidly review kind of how these make sense. So let's say we've got a list. It could be an array list. It could be an array. It's called R. If I have nested loops like this, where the outer loop goes from 0 to the end of the array and the inner loop goes from 0 to the end of the array, the way to think about this is for each of the I values, we iterate over all of the j values before going to the next I value. So if we were going to trace this code, I initializes to 0, and you can see my finger here is intended to represent the value of I. And then we initialize j to 0 also, so I and j both point at 0. But as I stays at 0, we're going to execute this entire j loop. So as I is 0, we look at 0, 0, and then j iterates to 1, 2, 3, 4, 5, 6, all the way to the end of the list. And then once j is at the end of the list, the inner loop is done. And so now we go to the second loop of the outer loop. So we hit the I++, now I is 1, and j reinitializes to 0. And then j starts at 0 and loops through all of the positions while I remains at 1. And then the inner loop is done, and we are at the third loop for I, so now I has gone up, and j initializes to 0 and continues. So this is like the master pattern that you want to remember. Like I is going to loop over all the things, and j is going to loop over all the things, but it happens where j loops first, where j goes through the entire list for each value of I think is a good way to think about it. So you can think about it this way. For each I value, visit all of the j values. In class, we talked about the idea that depending on what you're trying to do, you may not want I and j to look at the same element. For example, if we're looking for a pair of things where the two things have to be different from each other, this is going to visit all pairs, but it's going to also visit elements where I and j are the same, so it's not actually two different elements. So the conventional solution to this problem is to have I loop over all the locations, but j always starts at one element past I. So a good way to think about this is for each I value, visit all j values larger than I. Or if you're thinking about it as a list, you could think about it as visit all j values to the right of I. So if we're going to kind of look at this with our fingers, I starts at 0, but then we'd initialize j to be 0 plus 1. So j initializes here. And so as I is at 0, j will loop over all of the values. And if we're checking pairs of things, we'd be checking like this pair, this pair, this pair, this pair, this pair, and so on to the end. Then we're done with the inner loop, so I increases, and then j is going to initialize to I plus 1. So in this case, I is 1, so I plus 1 would be 2. And j loops through all the values to the end, and then it's done, and so I goes up, and then j initializes here and goes to the end. So the pattern is I is still visiting everything, and the j values are looping over everything that is larger than each I value, like this. So that's the standard solution for making sure that you don't visit the same element with both loops, and also making sure that you don't check the same pair twice. Because otherwise, I might check the thing at 2 and the thing at 4 one time when I is 2 and j is 4, but then later on, I is going to be 4 and then j would be 2. And so I'm checking the same pair of things. It's just that I checked them with opposite indices. So if you don't want to check the same pair more than once, this is also a solution to that problem. A few of the solutions we looked at. In one of them, we were going to loop over all combinations of a color, a font size, and a font style. So we were going to pass these three arrays into a method here. And for the first part of the problem, we were just going to display them. So that's the part that's commented out here. But I've got I looping over the entire colors list, j looping over the sizes list, and k looping over the styles list. And because all three loops are nested, it's like for each color, visit all of the sizes. And for each size, visit all of the styles. The second part of the problem was to not actually display them, but to take each different combination of elements and to create an object representing those. So here you can see I'm returning an array list of combination objects. Combination is just a class that I wrote myself, and here's what it looks like. So I thought, what does it mean to be a combination? Well, a combination has a size and a style and a color. So I made fields for those. I made a constructor, and I made a toString method for displaying it, and that's it. Oh, and it looks like I made one getter method, but you could make the rest of the getter methods. So once I have an object that represents a particular combination of elements, I can make an array list that's empty. And then as I loop over the different combinations of things, instead of displaying them, I'll take each of the things that I would have displayed and use them to construct a new object. And I call that object C, and then I add it to my list, and then at the very end I return the list. So instead of displaying things to the console, which is like great for you to look at to make sure it's doing something sensible, it's not very useful to display stuff to the console. But if we have a list of objects that represents each of the possibilities, then we could write more code that does something with each of those combinations. And so that's why this was helpful. Let's look at a couple of student answers. So this is a solution to the problem of displaying all possible passwords that only involve lowercase letters that are also 5 letters long. So the only somewhat strange thing here is making a 2-dimensional string array. I'm not really sure what the purpose there was, especially since we're only accessing 1 dimension. But if we make it a 1-dimensional string array, I'd said that you can use .split as a way of taking a string and breaking it at every single location. So this is just a quick way of making an array of letters A through Z. But the main brute force thing to understand is all the nested loops, and each loop loops from the beginning of the list to the end of the list. Because we want to be able to generate a password like GGGGGG. No, sorry, that was too many letters. GGGGG. Because, that's a possible 5-letter password. So I don't want to restrict the range that any of my letters would loop over. So just to be clear, I is like, what's the first letter going to be? J is like, what's the second letter going to be? K is like, what's the third letter going to be? And you can see on the inside here that we're accessing the letters array with index. So if what I just said was true, then it would be I as the first letter and then J as the second letter and so on. Here's a student solution to finding the point in a list that's closest to a target set of coordinates. So this student initializes the provisional answer as the first point in the list. Let's get the point out at the beginning and say, so far as we know so far, this is the closest. And it's okay for this to be anything because the whole idea is that we're going to loop over all the rest of the points and check them to see if any others are closer. Then they went ahead and made a new point out of the input coordinates and calculated what is the actual distance between this one that we claimed was the closest and the target, and saved that as shortest distance. So now that we've got an initial possible answer, maybe the first point in the list is closest, we're going to start with the next element in the list and loop through the entire rest of the list. And for each thing in the list, we want to answer one question. We want to say, is the next point in the list even closer than our best answer so far? So what they do is they look and see what's the distance from the next point in the list, pointList.getElementI, and find the distance from that to the target, and that's current distance. And so if current distance is smaller than the shortest distance we've seen so far, what that means is we have a new closest point. So we'll save this distance as the new shortest distance, and we'll save that point as the new best point so far. And then once we get to the end of the list, we can return the point as the best overall answer. And for this problem, that means the closest point to the target. For the problem where we're trying to find the largest triangle less than a particular target area, we're given a list of points, and we want to loop over all combinations of 3 points from the list, because it takes 3 points to make a triangle. And for each triangle, we want to find its area, make sure it's larger than our target area, Oh no, sorry, make sure it's smaller than our target area. And we're trying to find the biggest area that's smaller than our target. So if the target was 85, we want to make sure all of the triangles we're considering are smaller than 85, but then we want to return the biggest one that's smaller than 85. So it's a very similar pattern. We can initialize the largest area we've seen so far, and then loop over all combinations of 3 points. You can see here that this exhibits the same problem that I highlighted at the very beginning of the video. I and j and k can all be the same value here because they all start from 0 and go to the end of the list. But what would it mean if I and j and k are all like 4? What that would mean is that we haven't selected a triangle because we've selected 3 points that are all the 4th point in the list. And so it's really important that I and j and k represent different values from our point list, because only if you have 3 distinct points will you get a triangle. So the conventional solution from the beginning of the video was, let's make sure j is larger than I, and let's make sure that k is larger than j. Now we're guaranteed to visit all combinations of 3 points exactly once. This student has written a method to calculate the area of a triangle given 3 vertices. And so that's the current area. And so now we can do our checks. We can check if the current area is less than or equal to target, and if it's larger than the biggest area we've seen so far. And if it is, then we've found a better area, as this debugging print statement says. And so we'll save the area as the best so far, and we'll save the 3 points as our favorite answer so far. And then at the very end, we can return the answer.